flying at the back of his squadron's formation at roughly 28,000 feet. 23-year-old U.S. Army Air Forces pilot Robert Samuel Johnson tightened his grip on the control stick of his P-47C Thunderbolt. The 56th Fighter Group had crossed the English Channel only minutes earlier. 48 Thunderbolts were escorting B-17 bombers on their return from a strike against an airfield near Paris. Johnson had achieved his first aerial victory just weeks before and was still gaining experience in the unforgiving air war over occupied Europe. Raised in poverty during the Great Depression in Lawton, Oklahoma, Johnson was the son of a mechanic. Determined to fly, he took odd jobs for years and managed to earn his pilot's license one day before turning 16. Now he sat in the cockpit of one of the largest single-engine fighters ever produced, an aircraft weighing several tons and powered by an 18-cylinder Pratt & Whitney R2800 radial engine generating around 2,000 horsepower. Its 13-foot propeller could push the Thunderbolt past 400 miles per hour, making it formidable in both speed and firepower. Without warning, the formation was attacked. 16 Focke-Wulf FW-190 fighters from Jagdgeschwader 26, an elite German unit, dropped out of the sun from about 32,000 feet. Their initial attack disrupted the American formation. Johnson, flying in the vulnerable rear position, became the focus of concentrated fire. Cannon rounds whipped into his aircraft, shattering the canopy and severing hydraulic lines. Fluid sprayed into his face and eyes, partially blinding him. Shrapnel struck his right leg, and a bullet grazed the tip of his nose. Flames erupted in the engine. He attempted to bail out, but the canopy had been damaged and would open only a few inches, far too little for escape with a parachute. Eventually, the fire died out on its own when fuel lines failed. Nearly blind from chemical burns and struggling to maintain control, Johnson found himself flying a machine that had absorbed more than 20 direct 20mm cannon hits and hundreds of machine gun strikes. Most aircraft would have broken apart. Most pilots would not have survived. Yet the Thunderbolt stayed airborne. Encounters like this forced German fighter pilots to reconsider their assumptions about American aircraft design. Luftwaffe engineers and pilots had emphasized speed, agility, and efficiency, minimizing weight wherever possible. The American approach, at least in the case of the P-47, appeared radically different. The Thunderbolt was heavily built, capable of absorbing enormous punishment, closer to a flying armored vehicle than a delicate interceptor. This contrast highlighted a broader shift in fighter design philosophy and would influence aviation thinking long after the war. The P-47 Thunderbolt entered service with the U.S. Army Air Forces in November 1942. Its size and weight initially seemed to contradict established fighter design principles. The widely used P-47D variant had a maximum takeoff weight of about 17,500 pounds, making it the heaviest single-engine fighter of the conflict. By comparison, a Supermarine Spitfire weighed around 9,500 pounds, the Messerschmitt Bf-109G roughly 7,500 pounds, and the Focke-Wulf FW-190A about 10,800 pounds. German intelligence analysts reviewing early reports assumed the aircraft was a temporary or flawed design that would soon be replaced. That assumption proved entirely incorrect. The Thunderbolt was the work of Alexander Kartveli, a Georgian-born engineer who immigrated to the United States in the late 1920s and later joined Republic Aviation. His design priorities differed sharply from many European engineers. Rather than focusing primarily on reducing weight and maximizing elegance, Kartveli emphasized durability and pilot survival. The result was a fighter built to withstand extraordinary damage and still bring its pilot home, an approach that would leave a lasting mark on the evolution of military aviation. The Republic P-47 Thunderbolt was engineered with an emphasis on durability that few fighters of its era could match. At the core of its structure was an exceptionally strong wing spar, a single forged aluminum beam roughly 4 inches thick at the center and narrowing toward the tips. This component alone was capable of enduring forces up to 12 times the pull of gravity, roughly triple what would have torn apart a Messerschmitt Bf-109 under similar stress. The fuselage was built around the powerful Pratt & Whitney R2800 double wasp radial engine, but the aircraft's resilience depended on more than engine power. The design incorporated a network of protective systems and structural buffers that set a new standard for survivability. Positioned between the engine and the cockpit were the turbocharger assembly, intercoolers, oil coolers, and several fuel tanks. Internal fuel capacity varied by version. Early P-47B and C models held about 305 gallons, while the widely used bubble canopy P-47 D25 through D40 carried around 370 gallons. Late-war P-47N aircraft intended for Pacific operations pushed that figure to approximately 556 gallons. All of this fuel was housed in self-sealing tanks. Although self-sealing tanks had been introduced earlier by British engineers and later refined in the United States, the Thunderbolt employed them with remarkable effectiveness. Each tank was encased in layers of treated rubber that swelled upon contact with fuel, sealing punctures quickly. Enemy pilots learned that hits, which would normally ignite or destroy a fighter, often had little immediate effect. Bullet holes closed, fuel leaks stopped, and the aircraft remained operational. Protection for the pilot extended well beyond the fuel system. The cockpit was encased in substantial armor, informally described by American ground crews as an armored bathtub. Heavy plating shielded the pilot from multiple directions. Behind the seat sat hardened steel capable of stopping 20mm cannon fire at close range with additional armor integrated into the headrest. Another plate beneath the seat offered protection during low-level attacks from the ground. At the front, a thick bullet-resistant windscreen provided defense even against large-caliber rounds. For German pilots accustomed to lighter and minimally armored fighters, the Thunderbolt proved a surprisingly difficult adversary to bring down. Post-war interviews with German ace Heinz Bär, credited with 220 victories, reflected this challenge. He noted that the P-47 could absorb repeated hits and still remain in the fight. Cannon rounds visibly struck the aircraft, yet the pilot often continued flying, waiting for an opportunity to counterattack. The experience, he suggested, had a strong psychological impact on those attempting to shoot it down. One of the clearest demonstrations of the aircraft's toughness occurred during a major air engagement in June 1943. Robert Johnson's squadron was attacked by experienced German pilots, and tactics that had been effective against other American fighters proved far less successful against the Thunderbolt. Johnson's own aircraft suffered severe damage and entered a spin toward the ground. With great efforts, partially blinded by hydraulic fluid and struggling with failing controls, he managed to recover and level out. He then began a slow, difficult return toward England. A lone 5-190 soon appeared behind him, intent on finishing off the damaged fighter. The German pilot, likely Egon Meyer of JG-2, had already used his 20mm ammunition earlier in the mission but still had functioning machine guns. He made several firing passes, repeatedly striking the Thunderbolt. Johnson, flying just above stall speed and weaving to make himself a harder target, could only fire back in the general direction of his attacker. Despite the continued hits, the aircraft stayed airborne. After several passes, the German pilot apparently exhausted his ammunition. According to Johnson and a wingman who later rejoined him, the Fi-190 pulled alongside, its pilot briefly acknowledging the battered aircraft before turning away. Johnson managed to reach RAF Manston in Kent. With damaged controls, impaired vision, and an oil-covered windscreen, he brought the aircraft down and rolled to a stop. Inspection revealed the extent of the punishment: more than 20 direct 20mm cannon impacts, numerous machine gun strikes, a severely damaged tail, destroyed canopy, severed control lines, and ruined hydraulic systems. The Thunderbolt itself was beyond repair and salvaged for parts, but Johnson survived with relatively minor injuries and returned to combat within days. By the time his combat tour ended in May 1944, he had amassed 27 confirmed victories in the air. That total placed him among the leading American fighter aces and made him the first U.S. pilot operating in Europe to exceed Eddie Rickenbacker's World War I mark of 26 kills, yet the importance of Johnson's survival was larger than the fortune of a single pilot. Major David Schilling, operations officer of the 56th Fighter Group, quickly understood that the ruggedness of the P-47 Thunderbolt was altering the basic principles of air combat. Reports submitted throughout the summer of 1943, now preserved in U.S. Air Force historical archives, show that commanders in the 56th identified a major tactical shift. American pilots were flying aircraft that could endure levels of damage that would have destroyed most other fighters. This durability encouraged aggressive methods that would have been reckless in lighter planes. Thunderbolt pilots could continue attacks longer, hold firing angles that required flying through defensive fire, and most importantly, remain with bomber formations instead of disengaging at the first sign of damage. The aircraft's strength did more than keep pilots alive. It changed how they fought. German fighter leaders soon realized that their established tactics were becoming ineffective. Their doctrine relied heavily on energy fighting, diving from superior speed or altitude, striking quickly and breaking away before the opponent could react. Against the P-47, this approach often failed. The Thunderbolt could absorb the initial blow and stay in the fight. In prolonged engagements, its advantages grew clearer. Its 8.50 caliber Browning machine guns lacked the individual punch of German 20mm or 30mm cannons, but together they delivered a sustained and reliable stream of fire. American guns were known for functioning consistently even during long engagements, while German cannon systems sometimes jammed, leaving pilots exposed at critical moments. By mid-1943, German tactical instructions began to reflect these realities. Documents captured after the war show mounting concern within the Luftwaffe. Fighter units were instructed to secure a kill during the first attack pass whenever possible. Pilots were warned not to assume that visible hits, smoke, or flames meant a Thunderbolt would soon fall. They were also cautioned against lingering in combat with damaged P-47 seconds, which frequently remained fully capable of fighting. These directives amounted to a reluctant admission. Even experienced German pilots flying aircraft they considered superior were being told to avoid drawn-out engagements with American fighters. The psychological impact was significant. As the strategic bombing campaign intensified in the summer and autumn of 1943, American B-17 and B-24 bombers pushed deeper into German territory, striking aircraft plants, oil facilities, and ball-bearing factories. P-47 groups, now operating in larger numbers, escorted the bombers. German fighter units, under pressure to stop the raids, committed heavily to intercepting the formations. The outcome proved costly for the Luftwaffe, not only in aircraft losses but also in morale and effectiveness. Attacking bomber streams meant flying through defensive fire from both bombers and their escorts. While bomber gunners could damage intercepting fighters, they rarely destroyed them outright with a single hit. The Thunderbolt's guns, by contrast, were often lethal when they connected. Even more discouraging for German pilots was seeing American fighters continue flying despite damage that should have been fatal. Major Gunther Rohr, one of the highest-scoring aces in history with 275 victories, conducted most of his missions on the Eastern Front, where he achieved remarkable success. In August 1943, he flew a single mission against American bombers in the West and did not repeat the experience. After the war, he explained that on the Eastern Front, a solid hit on a Soviet fighter usually brought it down. Aircraft like the Leg-3 or Yak-1, even later versions, were comparatively fragile. In the West, however, he recalled attacking a Thunderbolt from an ideal position at close range and firing everything he had. He saw debris and hits across the fuselage and wings, yet the American aircraft kept flying, turned, and nearly shot him down. Afterward, he requested to remain in the East, where he felt the odds were better. Such views became increasingly common among Luftwaffe pilots. Despite the heavy risks in the East, many found it psychologically easier to face Soviet fighters, which could be destroyed more predictably. Thunderbolts, by contrast, seemed exceptionally hard to bring down. Statistics reinforced these impressions. In 1943, the P-47's combat loss rate per sortie was about 0.7%, compared with roughly 1.2% for Spitfires and 1.4% for P-38 Lightnings. Even more striking was the repair rate. More than 90% of damaged Thunderbolts that returned to base were repaired and back in service within a week. Aircraft riddled with holes could still fly home, be patched, and rejoin operations shortly afterward. German intelligence eventually gained a clearer understanding of why the aircraft proved so resilient. Captured P-47 seconds were transported to the Rechlin Test Center, where Luftwaffe engineers studied them in detail. Reports found in German archives after the war reveal both respect and frustration. Engineers noted that the Thunderbolt's design emphasized durability rather than minimum weight. Where German fighters used thinner aluminum and minimized fasteners to save mass, the P-47 employed thicker materials and more robust construction. German designs often relied on single structural load paths for efficiency, whereas the American aircraft incorporated redundancy. If one structural member failed, another could carry the stress. If a control cable was cut, backup systems remained. The plane had been built with the expectation that it would take damage in combat and still need to return its pilots safely. A German technical report from late 1943 summarized this contrast in design philosophy, highlighting the different priorities that shaped the aircraft on each side. From a German engineering perspective, American fighter aircraft appeared wasteful. Their designs relied on far more material than was strictly necessary for structural strength. Extra systems were duplicated, increasing weight, and maneuverability was often traded away in favor of armor and durability. By traditional performance standards, this approach seemed flawed, yet in practice it proved brutally effective. American pilots frequently returned from missions and flew again, while German aviators operating lighter, more agile machines were lost in greater numbers. The two sides were solving different problems. Germany had built fighters to dominate aerial duels. The United States had built aircraft meant to endure long campaigns and ultimately win the wider war. German industry produced exceptional machines. The Bf-109 outpaced the P-47 at many altitudes below roughly 25,000 feet. The Fu-190 could turn more tightly. By 1944, the Me-262 jet was faster than any Allied fighter, but superior speed and maneuverability mattered little if the pilot did not survive repeated missions. American designers recognized that experience accumulated only if pilots lived long enough to gain it. A veteran flyer in a rugged aircraft, even if less nimble, could defeat an inexperienced opponent in a high-performance machine. More importantly, survivable aircraft produced more veterans. By late 1943, the air war over Europe entered a new phase. Allied bombers were pushing deeper into German territory. Once the P-47 received jettisonable external fuel tanks, its range extended enough to escort bombers far beyond earlier limits. German fighter units now faced escorts that were difficult to destroy. Reports from the front indicated that bringing down a single Thunderbolt often required far more ammunition than expected. Many pilots emptied their guns into one aircraft without success. Even if they survived the encounter, they returned to base with no ammunition left, unable to attack bombers or other fighters. Entire formations were being neutralized not by losses but by expending their firepower on aircraft that refused to fall. General Major Adolf Galland, who oversaw German fighter forces for much of the war, attempted to counter this situation. In October 1943, he instructed pilots to ignore American fighters and concentrate on the bombers, arguing that destroying the bomber formations would end the threat. The plan failed. American escorts, confident in their aircraft's durability, adopted increasingly aggressive tactics. Rather than remaining defensive, they attacked German formations directly, often diving through defensive fire and breaking up attacks before they reached the bombers. One of the most prominent American pilots of this period was First Lieutenant Francis Gabreski of the 56th Fighter Group. The son of Polish immigrants, he flew with a personal sense of purpose. Relatives of his remained. In Nazi-occupied Poland, his combat style made full use of the P-47's strengths. He targeted German fighters attacking bombers, attacked from above, absorbed incoming fire if necessary, and closed in for powerful machine gun bursts at short range. Between August 1943 and July 1944, he destroyed 28 enemy aircraft, becoming the leading American ace in Europe. He survived hundreds of sorties, often returning with a heavily damaged plane, an outcome that reinforced the aircraft's reputation. The winter of 1943-44 marked one of the most intense phases of the European air campaign. German aircraft factories were under constant bombardment. Despite ongoing production, the Luftwaffe struggled to replace experienced pilots lost in combat. Meanwhile, American P-47 units grew in strength and confidence. Training in the United States emphasized the aircraft's resilience. Instructors told new pilots that their fighter could withstand punishment that would destroy most others and encouraged them to press attacks rather than disengage. Major Hubert Hub Zemke of the 56th Fighter Group formalized these ideas into doctrine. His unit adopted loose, flexible formations later associated with his name that allowed rapid reaction instead of rigid, close spacing. When attacked, the P-47 seconds often turned toward the enemy, forcing head-on engagements where armor and heavy armament favored them. German pilots accustomed to opponents who evaded combat suddenly faced adversaries willing to fly into gunfire and keep coming. By early 1944, the strategic balance had shifted. The longer-range P-51 Mustang began to appear in greater numbers, supplementing Thunderbolt groups. Even so, the P-47 remained the primary escort for many missions. Its durability made it especially valuable for the most hazardous tasks, entering heavily defended airspace first, escorting bombers over key targets, and attacking German airfields. While the P-51 excelled in speed and maneuverability, commanders still relied on the Thunderbolt when survival under heavy fire was essential. In February 1944, Allied air forces launched Operation Argument known as Big Week to cripple German fighter production. Over 6 days, American and British bombers flew thousands of sorties against aircraft factories, supported by massive fighter escort. P-47 groups carried much of the burden during daylight operations. Hundreds of German fighters were destroyed during the campaign, while Thunderbolt losses remained comparatively low. German pilots, compelled to defend their factories and bases, engaged despite mounting risks and suffered severe casualties. After-action reports from German units revealed growing discouragement. Pilots described repeatedly hitting Thunderbolts that continued flying and fighting. Some sought transfers away from the Western Front. Others reported mechanical issues that conveniently kept them grounded. Personnel investigations found widespread reluctance to face American formations, with encounters against P-47 seconds frequently cited as a major factor. By the summer of 1944, the Thunderbolt took on an additional role. Its ability to withstand heavy damage made it well suited for low-altitude strikes against ground targets. What had once seemed an inefficient, overly heavy design proved adaptable and resilient across multiple missions. An aircraft built not merely to win aerial contests, but to endure the demands of a long and destructive war. The Republic P-47 Thunderbolt earned a reputation for durability that set it apart from most fighter aircraft of the Second World War. While many fighters were highly vulnerable to anti-aircraft fire during low-level missions, the P-47 could push through heavy defenses, release its bombs or rockets, and still make it back to base despite severe damage that would have destroyed lighter planes. In June and July of 1944, P-47 units flew thousands of sorties in support of Allied forces advancing inland from Normandy. German troops quickly learned to fear the deep, distinctive sound of its radial engine and nicknamed the aircraft Jabo, a shortened form of fighter bomber that carried an unmistakable sense of dread. One notable example of the aircraft's resilience involved Second Lieutenant Robert Harmon of the 362nd Fighter Group. On July 25, while striking German positions near St. Louis, his aircraft was hit repeatedly by 37mm anti-aircraft shells. One blast tore away several feet from the tip of his right wing. Another penetrated the engine, destroying 2 cylinders and briefly igniting a fire. A third shell struck the tail and cut the elevator control cables. Harmon managed to stop the engine fire by shutting down and restarting the power plant, then used trim controls to compensate for the lost cables and regain limited control. Despite the damage, he flew roughly 150 miles back to England with an engine operating on only 16 of its 18 cylinders. The aircraft was written off and stripped for parts, but Harmon survived unharmed and went on to complete 89 additional combat missions before the war ended. Ground crews often joked grimly about the Thunderbolt's ability to keep flying. Their humor suggested the aircraft needed only a partially functioning engine, at least one working control surface, and a determined pilot. Behind the jokes was a widely accepted reality. The P-47's toughness was so well known that anything short of total destruction seemed routine. German anti-aircraft units equipped with 20mm, 37mm, and even 88mm guns discovered that downing one often required far more hits than expected. Standard estimates held that a fighter could be destroyed by just a few 20mm strikes, yet reports from the field suggested that P-47 seconds sometimes absorbed 10 or more direct hits and still reached friendly territory. Its radial engine was especially hard to disable. Unlike inline engines that could fail quickly after a cooling system strike, the P-47's engine could lose multiple cylinders and continue producing enough power to stay airborne. In the Pacific, the Thunderbolt also proved effective from 1943 until the end of the war. The long-range P-47N variant was designed specifically for operations across vast ocean distances. With expanded internal fuel capacity and additional external tanks, it could escort B-29 Superfortress bombers on missions against Japan and provide close air support throughout the island-hopping campaigns. Units such as the 318th Fighter Group flew extended escort flights from bases near Okinawa, sometimes covering more than 1,500 miles round-trip to targets over Japan. The same durability that served pilots well in Europe remained vital in the Pacific, where both enemy fighters and ground fire posed constant threats. The last major air engagement in the European theater occurred on January 1, 1945, during Operation Bodenplatte. In a final attempt to cripple Allied air power, the Luftwaffe launched more than 850 fighters in coordinated attacks on Allied airfields in Belgium and the Netherlands. Although the strikes initially destroyed over 300 aircraft on the ground and damaged many more, the German losses proved devastating once Allied fighters scrambled to respond. By day's end, the Luftwaffe had lost 271 aircraft, along with a large number of experienced pilots and commanders. These losses were impossible to replace. P-47 units were active throughout the day. Most of their losses occurred on the ground during the opening attacks rather than in aerial combat. Despite facing superior numbers in several engagements, no Thunderbolts were shot down in air-to-air fighting during the operation. German pilots later described a familiar frustration. Repeated hits on P-47 seconds often failed to bring them down. Major Gerhard Barkhorn, one of Germany's highest-scoring aces, recalled firing an entire ammunition load into a single Thunderbolt and observing numerous impacts before finally damaging a critical system. He remarked that the same ammunition might have destroyed several fighters on the Eastern Front. When the war concluded in May 1945, the P-47's record reflected its effectiveness. More than 15,000 were built, making it one of the most produced American fighters of the conflict. In the European and Mediterranean theaters alone, Thunderbolts flew over 500,000 combat sorties. They were credited with destroying thousands of enemy aircraft in aerial combat and many more on the ground, along with vast numbers of locomotives, railcars, and armored vehicles during ground attack missions. Perhaps the most significant statistic was the aircraft's low loss rate. In Europe, only about 7 P-47 seconds were lost for every 1,000 sorties flown lower than other American fighters of the time. This high survivability meant more pilots returned home safely. Among U.S. fighter pilots in the European theater, those flying the Thunderbolt experienced the highest survival rates. The engineering choices that made the aircraft strong and resilient ultimately saved many lives, even if its designers were primarily focused on performance rather than humanitarian outcomes. After World War II, many former Luftwaffe fighter aces spoke about the Allied aircraft they had faced. Again and again, they singled out one machine for its extraordinary durability, the Republic P-47 Thunderbolt. Their admiration was not based on elegance or aerodynamic superiority, but on its ability to survive punishment that would have destroyed most fighters. In interviews conducted after the war, General Adolf Galland was asked which Allied aircraft he respected the most. His reply rarely changed. He did not choose the fastest or most agile fighter. The P-51 Mustang outperformed others in speed and maneuverability, and the Spitfire impressed with its refined design. Yet Galland emphasized the Thunderbolt. In his view, it could absorb tremendous damage and continue flying. Pilots might strike it repeatedly with cannon fire, only to see it remain in the fight. That resilience created a psychological burden for German pilots who realized that even accurate attacks might fail to bring it down. Johannes Steinhoff, one of Germany's highest-scoring aces, later reflected on this in his memoir. He noted that Luftwaffe pilots respected different opponents for different reasons: Soviet flyers for their bravery, British crews for persistence, and Americans for their overwhelming resources. But he wrote that the P-47 inspired particular concern. To them, it symbolized American industrial power in physical form, an aircraft built with so much structural strength and protection that it challenged their idea of what a fighter should be. German designs tended to prioritize efficiency and performance, while the Thunderbolt resembled a heavily armored combat machine. In the long run, Steinhoff suggested that philosophy proved decisive. Post-war research supported these impressions. The United States Strategic Bombing Survey analyzed thousands of combat reports, maintenance records, and recovered aircraft. The data showed that the P-47 generally required more hits to destroy than other Allied fighters. German pilots often had to expend a disproportionate amount of ammunition to shoot one down. Because their fighters carried limited supplies, roughly a few hundred cannon rounds and about 1,000 machine gun rounds. Firing heavily at a single Thunderbolt could leave them vulnerable to other American aircraft encountered during the same mission. Engineering factors explained much of this toughness. The aircraft's radial R2800 engine could continue operating even after losing multiple cylinders because the remaining ones shared the workload. Its large propeller retained enough momentum to keep turning and provide thrust even when engine power dropped. Significantly, the airframe was designed with redundant structural pathways, allowing it to stay intact despite severe damage. Self-sealing fuel tanks reduced the risk of fire after punctures, and armor protected not only critical components but also backup systems. As a result, pilots often retained control even when primary mechanisms were compromised. The Thunderbolt's reputation influenced later fighter development. After studying combat experience from World War II and Korea, US, planners concluded that survivability mattered as much as speed or maneuverability. Subsequent aircraft, from the F-86 Sabre to the F-4 Phantom, incorporated redundant systems, protected vital components, and design features intended to help pilots return home. Similar conclusions emerged elsewhere. Soviet engineers, examining captured data and conducting their own studies, also began emphasizing protection more strongly in post-war fighters. Today, the legacy of the P-47 still shapes military aviation thinking. Modern fighter programs place significant value on pilot survival and mission completion. The A-10 Thunderbolt II, named in honor of the earlier aircraft, embodies the same principles. Its armored cockpit, backup control systems, and ability to remain airborne despite severe damage all echo the philosophy that guided the original design. The human stakes of the air war highlight why this mattered. Of roughly 13,000 American airmen who served in Europe, about 26,000 were killed. Loss rates varied by aircraft and mission, but P-47 pilots experienced lower fatality rates than some of their counterparts. Over a full combat tour, roughly 12% of Thunderbolt pilots were killed, compared with about 18% among P-38 crews. Those numbers underscored a central lesson. An aircraft that could protect its pilot and bring them home offered an advantage beyond raw performance. Losses among B-17 and B-24 bomber crews were severe, reaching roughly 1 in 5. In contrast, the rugged construction of the P-47 fighter had a measurable human impact. Thousands of American airmen survived missions that might otherwise have killed them. Many returned home, raised families, and lived long lives. The design philosophy behind the Thunderbolts, prioritizing durability and pilot protection, translated directly into saved lives. German fighter pilots who made it through the war retained a lasting respect for this aircraft. When West Germany rebuilt its air force within NATO during the 1950 seconds, former Luftwaffe aviators found themselves flying alongside Americans, including men who had once flown P-47 seconds against them. Conversations between these former enemies often turned to aircraft design and combat tactics. Veteran newsletters and reunion records show a pattern. German pilots admired the Thunderbolt's engineering resilience, while American pilots respected German flying skill. Both sides recognized that the P-47's ability to keep pilots alive had strategic consequences. It did not dominate through agility alone. Instead, it preserved experienced airmen long enough for them to improve, survive, and eventually prevail. In 1961, Republic Aviation organized a large reunion for former Thunderbolt pilots. More than 2,000 veterans attended, representing nearly every fighter group that had operated the aircraft in combat. Colonel Hubert Zemke, who had commanded the highly successful 56th Fighter Group, the leading P-47 unit with hundreds of aerial and ground victories, delivered the keynote address. His remarks reflected the shared sentiment of many pilots. The Thunderbolt was not the fastest, most maneuverable, or most elegant fighter of its era. What mattered was that it consistently brought its pilots back. For young men flying high over hostile territory, survival outweighed all other performance measures. Those who built the aircraft, he emphasized, understood that their engineering choices determined whether crews lived or died. The aircraft's nickname, Jug, derived from Juggernaut, reflected its reputation. It could absorb heavy damage and still return to base. German pilots often found that even when they hit a Thunderbolt, repeatedly causing smoke, fuel leaks, or visible structural damage, it remained airborne. This reliability had a psychological effect. Confidence among German interceptors declined as they realized that destroying the aircraft was difficult and costly. Some engagements were broken off early. In other cases, German pilots avoided combat altogether. The persistence of the P-47 altered tactical behavior as much as its firepower did. A telling evaluation came from one of Germany's highest-scoring aces in a late 1950 seconds interview with an American aviation publication. Asked to identify the most important Allied weapon, he did not choose the atomic bomb, heavy bombers, or long-range escort fighters. Instead, he pointed to the P-47. In his view, its greatest contribution was that it kept American pilots alive. Without trained pilots, an air force cannot function. Without an effective air force, victory becomes unlikely. German aircraft such as the Bf-109 and Fe-190 often outperformed the Thunderbolt in specific flight regimes, and jet technology represented a major advance. Yet performance advantages meant little if pilots were lost faster than they could gain experience. The Thunderbolt allowed its crews to survive early mistakes, learn, and become increasingly effective. By 1944 and 1945, many of the experienced American fighter pilots dominating European skies had accumulated that experience in P-47 seconds. The aircraft did more than shield individuals. It helped build a cadre of seasoned aviators who shaped the outcome of the air campaign. Today, only a small number of Thunderbolts remain airworthy, maintained by museums and collectors. When they appear at air shows, elderly veterans sometimes attend. They stand beside the aircraft they once flew, recalling missions and lost comrades. On occasion, German veterans are present as well. Conversations between former adversaries are marked by mutual respect. Americans acknowledging German skill and determination, Germans noting the resilience and treatment of prisoners by their opponents. Both groups often focus on the aircraft that once stood between them in combat. The Thunderbolt's legacy extends into modern fighter design, where protecting the pilot is often considered as important as achieving peak performance. Its example demonstrated that survivability can shape the broader course of a conflict. An aircraft that preserves its crews allows them to accumulate experience and effectiveness over time. In this sense, the P-47's greatest strength was not only its armament or speed, but its capacity to endure damage and return home. The Thunderbolt was rarely the top performer in any single category. However, in the harsh arithmetic of wartime aviation, durability proved decisive. German aces later acknowledged that while their own fighters were often faster or more agile, they lost too many trained pilots to maintain an advantage. the P-47 ensured that American pilots remained in the fight long enough to tip the balance. Its design philosophy, placing survival at the center, became one of the defining factors in the Allied air war over Europe.